Today we're looking at bases other than e. So yesterday we did exponential functions with bases of e. Today we're looking at bases other than e. This is just some practice finding the second derivative. Don't want to worry about that right now. This is what's going to come in handy for us. This is called the change of base formula. This will help us determine a general formula for our bases other than e. So let's take this log base a of u. We're going to use that change of base formula, which says we'll do natural log of u over natural log of a. Now, a in this case is a constant. It's the base of this exponential. And we're going to do the derivative of that. Well, since a is a constant, we can say this is the derivative of 1 over natural log of a times natural log of u. And then we're doing the derivative, this is a constant, so we're really just doing the derivative of natural log of u. So this becomes 1 over u natural log of a. That, then times du over dx. So times the derivative of the inside. Okay, so that's the general idea. Now you can apply this formula as you need. You don't have to apply it though if you can remember the general formula. So you can apply change of base if you need to, or you can use the general formula. So like for this one, if we remember the general formula, we can just say this is dy over dx equals 1 over x natural log of 6. Or if we wanted to do the change of base formula, we could say this is natural log of x over natural log of 6. Natural log of 6 is a constant, so this is going to be 1 over x times natural log of 6. Either way gives us the same answer. I think remembering the formula is going to make things a lot easier for you in the long run, especially when you do something like the second one with chain rule. So we're going to have 1 over 3x minus 2 times natural log of 7. That's our outside, times the derivative of the inside, so times 3. We'll go ahead and move that to the top. So 3 over, and then that right there. Okay, now this can also help us find a general formula for an exponential with a base other than e. So let's use that same thing. Let's do that natural log, or that log property, but instead, when we do our logarithmic differentiation here, we're going to use a log with the matching base. We'll say log base 3 of y equals log base 3 of 3 to the x. Same way we found the derivative for e to the x yesterday, we're going to do that for 3 to the x today. So this is going to be log base 3 of y equals, and then just x. Now we'll take our derivative, so it's going to be 1 over y natural log of 3 times dy over dx equals 1. So dy over dx equals y natural log of 3, which equals 3 to the x natural log of 3. So our general rule for exponents other than e for derivatives when we're doing exponentials, if you're doing the derivative of some exponential other than e, so where a is something other than e, it's going to end up equaling a to the u times natural log of a times the derivative of your inside, of your u. So we're going to apply that here. We're going to say this is 5 to the 2x minus 1 times natural log of 5 times the derivative of the inside, which is 2. So we end up with 2 natural log of 5 times 5 to the 2x minus 1. And we see that formula written out here. Now, this also lets us find an integral formula for it. We can say the integral of a to the x is 1 over natural log of a times a to the x plus c. So, looking at this one, we could say u is equal to negative x squared, du is negative 2x, so we have negative 1/2 integral 5 to the u du. So we're going to have negative 1/2, 5 to the u stays the same, but we have to multiply in that 1 over natural log of 5, then plus c, and plug back in our u, so negative 5 to the negative x squared over 2 natural log of 5 plus c. All right, you can try the second one on your own if you need to. Now, this leads us to this problem right here. This one's a little bit different. we're just going to use the logarithmic differentiation, and we're just going to use natural log. We'll say natural log of y equals natural log of x to the x, so x natural log of x. So we have 1 over y dy over dx equals, this is product rule, so x times 1 over x plus natural log of x times 1. So dy over dx equals y times 1 plus natural log of x, and plug back in our y, which is x to the x times 1 plus natural log of x. So this is not a derivative you can remember because there are too many x's and things going on. You would have to do this process every time if you ever see x to a power of x as well. All right, that's everything for me. You'll have a great day. Let me know if you have any questions.